This is my math project on Euclid's Elements. Ladies and gentlemen, prepare to embark on a time-traveling adventure to the bustling, sun-soaked city of Alexandria, Egypt, around 300 BCE. Picture it, a vibrant hub under the rule of Ptolemy I, the rock-star general turned scientist. Alexandria wasn't just any port city, it was the intellectual Las Vegas of the ancient world, with libraries so grand they'd make the Library of Congress look like a corner bookshop. Imagine shelves upon shelves of scrolls, each one brimming with philosophical and scientific musing, just waiting for curious minds to devour them. Now, in the midst of the scholarly paradise, we find young Euclid. Not much is known about his early schooling, which is a fancy way of saying historians are still scratching their heads. However, some believe that Euclid might have packed his bags and set sail for Athens, Greece, to attend the legendary Plato's Academy. You see, Plato's Academy wasn't just any school, it was the Hogwarts of ancient Greece, minus the wands but with a lot more geometry. According to the history of mathematics and technology, Plato's Academy was renowned across the land for its relentless pursuit of mathematical brilliance and intuitive thinking. Who needed magic when you had the power of Euclidean geometry? Despite the shroud of mystery around Euclid's upbringing, his words spoke volumes. He was like the ultimate math geek, showing off his deep understanding of his predecessors. Ever heard of Exodus of Cnidus, Plato, and Hippocrates of Chios? These guys were the OGs of mathematics, and Euclid was their absolute fanboy, observing their knowledge like a sponge. Euclid's motivation behind penning the Elements? Think of him as the original math influencer, aiming to compile and organize the chaotic world of geometry into a sleek, user-friendly package. Fueled by a desire for mathematical clarity and a touch of perfectionism/OCD, Euclid sought to create the ultimate go-to guide for all things geometric, making sure future generations wouldn't have to struggle through the math wilderness without a roadmap. Introducing the Elements. Far from being just an ancient collection of dusty scrolls with cryptic diagrams, it's the very blueprint of modern mathematics. Calling the Elements a simple geometry book is like calling the Mona Lisa just a portrait. With its 13 volumes, you'll find not just the beloved Pythagorean theorem, a squared plus b squared equals c squared, but a treasure trove of mathematical principles that have shaped the way we understand the world today. One of Euclid's most brilliant contributions was his use of the axiomatic method. Euclid starts with a few rock-solid axioms, basic truths so self-evident they make 2 plus 2 equals 4 look like a complex puzzle. These axioms are like the Lego bricks of logic. Euclid then uses these bricks to build a towering structure of knowledge, one theorem at a time. Imagine constructing a Lego skyscraper with pieces that snap together so perfectly the whole thing could withstand a hurricane, or, in Euclid's case, the test of time. But Euclid wasn't just stacking bricks, he was orchestrating a mathematical symphony. Each axiom was a simple note, each definition was a melody, and each theorem was a harmonious chord. The result? A magnum opus that not only includes the Pythagorean theorem, but also lays down the principles that form the backbone of modern geometry. So, next time you find yourself muttering under your breath about a tricky geometric proof, take a method to appreciate the ancient brilliance of Euclid. His axiomatic method isn't just a relic of the past. It's a testament to the power of logic thinking and the enduring legacy of one of history's greatest minds. And who knows, maybe next time you solve for X, you'll do it with a little more swagger, knowing you're following in the footsteps of the original math wizard himself. The axiomatic method has influenced some of the greatest minds of all time. First, Baruch Spinoza. This philosopher took Euclid's method and applied it to his own work, Ethics. Starting with definitions and axioms, he built his arguments logically, much like constructing a sturdy mathematical proof. Next, Isaac Newton. The physicist drew inspiration from Euclid when writing his Principia Mathematica. Newton's systematic approach laid the foundations for classical mechanics, showing how logical rigor can drive scientific discovery. René Descartes, the mathematician and philosopher, used the axiomatic method to develop Cartesian geometry. His emphasis on clear reasoning and logical deduction reshaped both mathematics and modern philosophy. Finally, Thomas Hobbes applied Euclid's method to political philosophy in his work Leviathan. By using clear definitions and logical deductions, he argued for a strong centralized authority, demonstrating the power of axiomatic approach in understanding the human society. Picture the Enlightenment, An age of powdered wigs, grand ideas, and the occasional snazzy waistcoat. Enter Euclid, the ancient Greek math whiz whose axiomatic method was the secret sauce behind it all. His work, The Elements, was like the IKEA manual for building a universe of logical thought, minus the frustration of missing screws. Enlightenment heavyweights like Spinoza, Newton, Descartes, and Hobbes were all following the method of Euclid, specifically the axiomatic method. Spinoza used Euclid's method to construct his philosophy as meticulously as a Jenga tower. Newton applied it to physics, making sure the apple didn't fall far from the axiomatic tree. Descartes, with his catchy "I think, therefore I am," brought Euclid's clarity to philosophy. And Hobbes, he used it to build his political theories, proving that even governments need a solid foundation. So, the next time you ponder the age of reason, tip your tricorn hat to Euclid, the grand architect behind the Enlightenment's towering intellect. Finally, let's return back to the Elements, Euclid's magnum opus, which is the most important math book ever written. Imagine trying to study geometry without a clear guide. Total chaos, right? Euclid swooped in around 300 BCE and organized all existing knowledge into a logical, coherent framework. He started with a handful of basic, self-evident truths known as axioms and built up the entire structure of geometry from there. The Elements isn't just about pretty shapes and figures. It's the foundation of logical thinking and proof in mathematics. Euclid's systematic approach has influenced everything from the development of calculus to modern computer science. Without the Elements, the mathematical world as we know it would be like trying to navigate a maze blindfolded. Euclid gave us the map, and for that we owe him a tremendous debt of gratitude.